Hi, in this video we will learn the second part of the fundamental theorem of calculus. This is the tool we have been looking for. It will help us to evaluate definite integrals. Okay, let's see what it says. Fundamental theorem of calculus part 2, this is how I will write it. Assumes that we have a continuous integrand, so let f be a continuous function. On the interval AB. Okay, if we know one antiderivative of this function, so if capital F is an antiderivative of the integrand, the f, well, you know what is antiderivative. Antiderivative is a function whose derivative is equal to integrand. Then we can easily evaluate what is the definite integral of f of x from a to b. Well, fundamental theorem of calculus part 2 says that this is equal to this value, right? But what we mean by that is that's just notation. It means that, let me write that, it means that you evaluate the antiderivative at the upper limit and then evaluate the antiderivative at lower limit and subtract. So you see that this will give us, the right hand side gives us a number, and that is equal to the definite integral the value of the definite integral we were looking for. Well, you see that this says that to evaluate a definite integral, you need to find an antiderivative. So based on FTC part 2, fundamental theorem of calculus part 2, to evaluate a definite integral, we need to find an antiderivative of the integrand. And that's it. You don't need to be worried about anything else. Remember, the definition of definite integral was limit of Riemann sums. You don't need to do any of those things. You just find an antiderivative of the integrand and evaluate that function at the upper limit minus the value of the function lower limit. That will be equal to value of the definite integral. Another remark is that, well, you may say that, okay, antiderivatives of a function had this plus c. So note that if f is an antiderivative of f, then any other antiderivative derivative of lowercase f is of the form, well, remember, what was it? So if you find one of the antiderivatives, then you add any constant to that, it will be the set of all the antiderivatives are of that form. Yeah. Well, now this is a question. So if I choose one antiderivative and someone else chooses another antiderivative, and we use the fundamental theorem of calculus, how do we know that we don't get different values? Well, let's see why. Because if I am looking for value of this guy, this is going to be same, well, let's say you use fx plus c as the antiderivative, and integral of that by fundamental theorem of calculus is going to be f of b plus c, this is a constant, minus f of a plus the constant, same constant c. But if you open this up, you see that this is minus f of a minus c. This c and that c cancel each other. And what we found here is that this is f of x evaluated at upper limit minus evaluated at lower limit. What this says is that doesn't matter which one of the antiderivatives you take. The difference of the values of that antiderivative at upper minus lower is going to be the same number. So there is no issue of which one of the antiderivatives you want to choose. Okay.